Okay, so this is the unit circle and everything that you need to know about it. And then we're going to be working with this a tremendous amount in the next couple of lectures. Okay. Okay. Here's the thing though. When we measure our angles right now, we're measuring them in degrees. But angles aren't just measured in degrees. Angles are measured in different ways, just like distance is measured in different ways, and weight is measured in different ways. Volume is measured in different ways. We have lots of different ways of measuring. We have lots of different units of measurement, right? So distance could be meters, it could be feet, it could be inches, it could be yards, miles, kilometers. We have lots of different ways. And typically we have two systems. We have an English standard system, that's your inches, your feet, your yards. If you're talking about distance, if you're talking about weight, it would be pounds and ounces. Or you have your metric system, which is what's used around the rest of the world. And your metric system in distance, it would be kilometers, centimeters, meters. In weight, it would be kilograms, grams, milligrams. So we have these two different systems, okay? When we measure angles, we have different units of measurement where one unit is in the same system and it might be smaller, okay, a smaller unit of the same thing, or it's in a completely different system, okay? So let's talk about how we measure angles. And then we're actually going to come back to this unit circle. So we have two systems. The first system is degrees, and then smaller than degrees is minutes, and smaller than minutes is seconds. So think of this like your feet, and then your inches is smaller than feet. So if I were to ask you what's your height, you might say I'm 5'4" okay? This is the same type of thing. Minutes is a smaller portion of the degree, okay? So there are 60 minutes in 1 degree. This is not surprising. Okay, so minutes, what we use is we use an apostrophe just like we would for feet, okay? 60 minutes and 1 degree. Okay, we're not even going to get into seconds. This is just if you want to say, well, I have 12 degrees in 10 minutes, okay? Minutes is not that surprising. Seconds is not that surprising. A circle, we have a clock has 60 minutes, right? When you go around the clock, so 60 minutes. And then we have, so it's not surprising that we use minutes as a smaller measurement of degree, okay? The second system is radians. Okay, now you can go between two systems. You can go between radians and degrees, okay? So let's talk about how this works, okay? I am going to try to demonstrate. This is a lot easier if I have a board and I could stand there and show you everything and how it works, but I'm going to do everything I can to make it as clear as possible. So radians, if you notice, it kind of looks like the word radius. That's because it actually is related, okay? So let's talk about what a single radian is, and then we'll talk about how to go between from one to the other, okay? So I'm going to go back to a circle. okay? Okay, so how does this work? So any circle has a radius of r, right? So if we want to come up with a single radian, what we would do is along the circle, you would think of like a string. You would take a string and you would measure out a length of r, okay? So now you have a string of length r. And instead of putting that string so that one end is at the center and the other end is on the circle, okay? What you're gonna do is you're gonna lay out that string over the arc of the circle. Okay? You're gonna lay out the string over the arc of the circle. And that would be equal to a single radian. So let's use green here. This distance here, would be r, okay? And when we connect this angle would be 1 radian. The angle that we create by connecting the end of that radius to the center gives us 1 radian, okay? So again, this length, okay, is equal to the radius, and then we can connect this point, the center, to this point at the end of that length, and the angle that we create is equal to 1 radian. If we do this again, so let's take a different color. Let's take this nice blue here. And we're going to lay out again our string that has a length of r. And we're going to connect to the center. And now this has a measure of 1 radian. So radian is an angle measure. Okay, so now from here to here is 2 radians. Okay, let's do this another time. So this time we'll use this orange color. So we're going to do it one more time. So this also has a length of r. If we connect this to the center, now we have this angle. This angle is 3 radians, is 1 radian. So now from here to here, we have 3 radians. And it turns out that from here to here, and I'll put this in black so it's very clear, this angle over here, this is approximately 0.14 radians. So if we take that string and we lay it out along the arc of the circle, we can lay it out 3.14 times and we'll get to halfway through the circle, okay? Now, what does this mean? We know that from here to here is 180 degrees. We labeled that on our axis over here, right? If we start here and we go halfway around the circle, we're at 180 degrees. So what does this tell us? This tells us that 180 degrees is equal to exactly pi radians. This is equal to pi radians. Okay, and it turns out too that, so this is exact. It's exactly pi. That's why I say that this is approximately 0.14, because it's like 0.14159 and so forth, okay? So 180 degrees is equal to pi radians. Now, the reason why we use radians, there are a few reasons. One big reason is that a lot of formulas are made much easier because we're using radians. So for example, if I wanted to find the length of this arc, if I'm in degrees, it's a much more complicated formula than just saying, oh, it's the length of r, okay? And what I could do is I could just, so we're not going over the formulas for arc length. We're not going over the formulas for the area that's within this section of the circle, okay? But if we did, you would see that the formulas are much simpler when we deal with radians. Another reason why we deal with radians is that it's a much smaller unit, okay? In the sense that in a circle, in half a circle, instead of there being 180 of them, there are only about 3.14. In a whole circle, we have 360 degrees. But for radians, we only have approximately 6.28 radians. So we're dealing with much smaller numbers, which makes our life much easier, particularly when we get to graphs later on. Okay, so this becomes much simpler. Okay. Okay. So let's start converting then. If we know that 180 degrees is equal to pi radians, so just a note before we do conversions, it's not necessary to write the unit. In other words, if there is no unit, the angle is in radians. That's what we're saying here. Okay, if there is no unit. So just like if there is no index in a radical, it's a square root. If there is no exponent of x, it's x to the first power. This is the same type of thing. If there is no unit, it's radians. That's because radians is used so frequently, and mathematicians can be very lazy. We don't want to put in the unit. And we can do that because there are not all that many different types of measurement. Think about the English standard system and the metric system, right? Metric system, we have kilograms, kilometers, millimeters, centimeters. We have loads. We have all of these different units. In the English standard system, we have pounds, ounces, inches, feet, yards, miles. We have lots and lots and lots of different units. So we wouldn't just say, okay, well, for this one out of the many different units, we're not going to write anything. Whereas here, it's essentially we have degrees, minutes, seconds, and then we have radians. So we can say, well, if there's nothing written, then we would say it's in radians, okay? So if there's no unit, then it's in radians. So we would say 180 degrees is just equal to pi. We wouldn't put the radians, okay? So if 180 degrees is equal to pi, now we can actually go through and we can figure out, for example, what 90 degrees is. So if you think about it, it's kind of obvious, right? 180 degrees is pi, 90 degrees is half of 180. So what's half of pi? We would just write pi over 2. And you always leave it in terms of pi. The reason why you leave it in terms of pi is it's so much more accurate, right? Pi is an irrational number. Anything that you write would be an approximation, so you would leave it in terms of pi. 45 degrees. Well, 45 is half of 90, so if we take pi over 2 and we divide that by 2, then it would be pi over 4. Another way to look at it is 45 degrees is 1/4 of 180 degrees. So this is equal to pi over 4. 360 degrees Well, 360 degrees is double 180. So 360 is double pi. So 360 is 2 pi. We could even go down here to this 270 degrees. Well, 270 degrees, it turns out, is 1.5 pi, right? Here's 1 pi, and then we're going another half pi. So 1.5 in fractions is 3 halves. So it's 3 pi over 2. So before we go any further, let's go back to our unit circle and put in how many radians each of these are. Okay, so this is 0 degrees. This is 0 degrees or 360 degrees, but it's also I didn't need to do that. It's also 0 or 360 degrees is 2 pi. And sorry for all of this formatting. I'm going to include this in the board notes. So I want to just make sure that it's clear. Okay. So it's 0 or 2 pi radians. Now when we get to 90 degrees is the same thing as pi over 2 radians. So 90 degrees is equal to pi over 2. Now 180 degrees is equal to 3 pi over, is equal to, I'm sorry, I didn't even have to do that. 180 degrees is just equal to pi. Okay, so at 0 degrees, we're at 0 radians. At 90 degrees, we're at pi over 2 radians. At 180 degrees, we said that we're at pi radians. At 270 degrees, we said that we're at 3 pi over 2 radians. And then when we go back to 360 degrees, we're at 2 pi radians. Okay, and what else does that mean? That means that the sine of 0 radians is 0. The cosine of 0 radians is 1. The sine of 2 pi radians is 0. The cosine of 2 pi radians is 1. The sine of pi over 2 radians is 1. The cosine of pi over 2 radians is 0, and so forth. So the sine and the cosine of 180 degrees is the same as the sine and the cosine of pi. Okay? And same thing here. Sine and cosine of 270 degrees is the same as the sine and the cosine of 3 pi over 2. Okay? Okay, but it's not always this simple, right? Because what if we wanted, for example, 35 degrees in radians? Now this is a little bit harder because 35 degrees, like 180 degrees, is pi. So we found that 90 degrees was pi over 2 because 90 degrees is half of 180. Okay, so half of pi is pi over 2. 45 degrees is a quarter of 180, so it's pi over 4. So the thing is that 35 degrees, we can't do that, okay? 35 degrees is not a factor of 180. So how do we convert from degrees to radians? Well, it's actually a relatively simple process because we can just do a part to a whole proportion, okay? So we could say part to whole is equal to part to whole. And one side of this is going to be your degrees. And one side of it is going to be your radians. So what we're asking is, what part of 35 degrees what part is of 180 degrees is 35? And whatever that part is, that's equal to x over pi. So our whole, now you could use 360 degrees and 2 pi so that you're thinking of it as whole circle is equal to whole circle, or you could use 180 degrees over and pi and 2 pi. So either way, your wholes is the whole piece. So you could think of it as half circles or whole circles. It doesn't matter, okay? So you have 35 over 180 is equal to x over pi. Well, what do we need to find? We need to find x. So our x this is the angle in radians. That's what we're trying to find. So we can cross multiply. Sorry, 35 pi is equal to 180x. Okay, if we are general about it, we could say theta over 180 is equal to x over pi. So notice that the 180 and the pi will never change. Okay, so when we cross multiply, we get 180x is equal to theta times pi, and then x is equal to theta times pi over 180. So that will always be true. So we can generalize it and say, well, to convert an angle from degrees to radians, you just take the angle that you're given and you multiply by pi over 180. But this is why, because you're constructing a ratio where you have part to whole is equal to part to whole. You cross multiply and you're solving for x. So we divide both sides by 180. Okay, and just like always, you always want to reduce. Okay, so our x is equal to 35 pi over 180. Leave it in terms of pi, but reduce. So both of these are divisible by 5. So it's 7 pi over 36. And this would be the angle in radians. Okay, so you're leaving in terms of pi, but you're reducing. Let's take another one. So we do the same thing. Part to whole, it's okay that our part is bigger than our whole, is equal to x over pi. So 200 pi is equal to 180x, or x equals 200 pi over 180. And you want to reduce. So both of these are divisible by 20. So you get 10 pi over 9. Okay, so you reduce, but you leave in terms of pi. Don't convert this to a decimal, okay? And don't convert your improper fraction into a proper fraction. Leave it as 10 pi over 9. Okay, let's do one more. Let's say that we have 50 degrees. So you do the same thing. You have your 50 degrees over your 180. Part to whole is equal to part to whole. Okay, you cross multiply, you get 50 pi is equal to 180x, and then x equals 50 pi over 180. These are both divisible by 10, so you get 5 pi over 18, okay, in its reduced form. Okay, so this isn't that bad, okay? You're setting up, you're always multiplying by pi over 180. Notice in each of these, we multiply by pi over 180. That's what's happening in all of them. We're multiplying by pi over 180. Okay, and the reason why this is an improper fraction is because 200 degrees is greater than 180 degrees. So this here should be greater than just pi. We multiplied 35 by pi over 180. Okay, so let's convert from radians to degrees. Okay, so typically our angles in radians are in terms of pi, meaning that the angle that you're given has a pi in it. But let's say it doesn't, okay? So we have two different possibilities. If the angle in radians is not given in terms of pi, right? We could be told that the angle is 1.57 radians. That's fine. There's nothing wrong with that. Okay, we typically leave it in terms of pi because when we plug it into our formulas, it makes our life much easier, but we don't have to. Okay, so here, let's suppose that we have 1.57. Well, if we do that, you're still going to use the part to whole over part to whole. You're still going to do degrees and radians. Here's your degrees. Here's your radians. So what does that give us? Same thing that we had before. It's our angle in degrees over the 180 is equal to our angle in radians over pi. That hasn't changed. So we cross multiply, we still get pi theta is equal to 180x. The difference is that we're not trying to find x anymore. We're trying to find theta. Okay, so now instead of dividing both sides by 180, because we know x, we're going to divide both sides by pi. Okay, that's going to cross this out, leave theta by itself. So notice what is happening here. Instead of multiplying the angle by pi over 180, we're multiplying the angle by 180 over pi. I'll write it as 180x because x 180 is such messy looking. Okay, so you're still setting up your part to whole equals part to whole. It's just that you're solving for theta now instead of solving for x. So instead of multiplying by pi over 180, we're multiplying by 180 over pi. So that means that if we're converting 1.57 from radians to degrees, we have theta over 180 is equal to 1.57 over pi. We cross multiply 180 times 1.57 is equal to theta times pi, or theta is equal to 180 times 1.57 over pi. And this is an angle in degrees. You would not leave it in terms of pi because it's an angle in terms of degrees, because it's an angle in degrees. So you would actually multiply 180 times 1.57 and then divide by pi, and pi is on your calculators. Okay, and this would give you 89.95 degrees. Okay, so it's an angle in degrees, so you would not leave it in terms of pi. Convert it to a decimal. Let's do one more. Okay, let's convert .81 radians, 2 degrees. Okay, so once again, we're going to set up our part over whole. So the degrees, the angle in degrees is unknown. So notice we're using theta because that's like a variable for angles. So theta over 180 is equal to 2.81 over pi. We can cross multiply here. So we get 180 times 2.81 is equal to theta times pi. And then we're dividing both sides by pi. So remember, this is the same thing as taking our 2.81 and multiplying by 180 over pi. It's just doing the opposite, right? The reciprocal. And once again, you would not leave it in terms of pi. You would actually put this into your calculator. Do 180 times 2.81 divided by pi. Again, pi is a button on your calculator. And you get 161.00 degrees. Okay, make it a habit to round to the nearest hundredth. I like the nearest hundredth. Okay. Now there's the other way to do this too. This is if the angle isn't in terms of pi. If the angle is in terms of pi, then it's really simple. we could just replace pi with 180 because pi equals 180. Okay, so for example, let's say that we want to convert 5 pi over 6 to degrees. Well, we have a pi in here. So what we're going to do is we're going to take 5 and we're going to replace the pi with 180 degrees. And if we do 5 times 180 over 6, we get 150 degrees. Okay, so notice I put 180 degrees in there because I want it to be clear that when we replace pi with 180, we're changing the units. Let's do one more. Let's convert 2 pi over 7 radians to degrees. So once again, it's nice and simple. We just take 2, and instead of multiplying by pi, we can multiply by 180 degrees. And we get 51.43 degrees. Okay, so nice, simple way to convert. And a lot of times you're going to be converting from degrees to radians. Sometimes you'll be converting from radians to degrees. There are going to be times when you're more comfortable working in degrees, so you're going to find the angle in degrees and then convert to radians, or vice versa. But you should be pretty comfortable with both, okay? So very quick summary of what we did, because there was a lot in there, okay? We first looked at the unit circle. We defined the unit circle as a circle with radius 1 and center at 0, 0. And we said, okay, well, first, what's the equation of the unit circle? So to find an equation, we look at a relationship between x and y. That's what every equation is. It's some relationship between the x and the y values that will give us all the points on the graph. So we took any point on the circle and we labeled it x, y, and then we saw that we could create a right triangle using that, okay? So when we create the right triangle, the horizontal distance is x, the vertical distance is y, because to get to the point x, y, we go over x and up y, and the diagonal, or the hypotenuse, is 1. So using the Pythagorean theorem, the relationship that we get between x and y is that x squared plus y squared is equal to 1. Okay. Now we said that we could do the equation for any circle with center 0, 0. Okay, the equation would just be x squared plus y squared is equal to r squared. So instead of having a radius of 1, we have a radius of r. And then if the center is at c comma d, then it would be x minus c squared plus y minus d squared is equal to r squared. Okay, that would be the equation for any circle with a center at c comma d, and that's because this is just a translation, okay? Okay, so then what did we do? We said, okay, well, this means that we call this angle theta. When we travel around a circle, we travel counterclockwise around the circle, and this is our starting point, and we're going to talk about this more in the next lecture. So here we have quadrant 1, we have quadrant 2, quadrant 3, quadrant 4, okay, traveling this way around the circle. So this is where we start. So this angle here would be called theta. And we said, okay, well, the sine of theta is equal to y over 1 in the unit circle. So our y values here are the sines of the angles. And the cosine of theta is equal to x over 1. So the x values here are the cosines of the angles. we were able to label the angles. So if we start here, that's 0 degrees, we also say that it's 360 degrees because when we go all the way around the circle, we're right back here. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then again, back to 360. Now we also labeled these angles in terms of radians. So in radians, this is 0. This is pi. Then we found that pi over 2 would be up here because this is exactly halfway to pi. This is 1.5 pi, so it would be 3 pi over 2. And then when we come all the way back around, we've went 2 halves of the circle, so we're at 2 pi, okay? Then we said, okay, well, let's do more specific conversions between degrees and radians. So to convert from degrees to radians, we could do a part to whole is equal to a part to whole, where one side is the degrees part to whole, and the other side is the radians part to whole. And we set it up as, okay, well, here's our angle in degrees. Our whole is 180 degrees. Again, you could use 360, but if you use 360, this should be 2 pi. And then our parts are the angles in degrees over here and the angle in radians over here, okay? Then we could just cross multiply. So depending upon what we're given, the other numerator is what's unknown, and that's going to be, we're always going to get pi times theta equals 180 times x. And if it's degrees to radians, we're going to be dividing by 180. If it's radians to degrees, we're going to be dividing by pi, okay? Over here, when you convert from degrees to radians, you leave your answer in terms of pi, but you reduce as much as possible. Now, if you're converting from radians to degrees, but your answer is given to you in terms of pi, you don't have to do that ratio. You can, but you don't have to. You can take the pi and just replace it with 180 degrees, and that'll give you your angle in